Thomas Eisner is a world expert on insects and their defence systems. He was born in Berlin in 1930, but grew up in Spain and South America after his family fled Nazi Germany. It was in Uruguay that Eisner fell in love with butterflies and moths. Now he lives with his wife Maria in upstate New York near Cornell University, where he's professor of neurobiology. His 7 wonders of the world include mosquito courtship, the firepower of the bombardier beetle, and music.
One of the early memories I have is finding a butterfly that obviously was hit by an automobile or damaged in some fashion. My mother took a sugar cube, drenched it in water, gave it to the butterfly, and out came its little proboscis, and it started feeding. That was a close observation that is so vivid in my memory. I can paint the broad strokes of the room, where at what corner of the dining room table we actually did that. And that must have been one of the really important events in my very early life. It involved a live insect. Sounds very corny, but there it is. You asked me to pick wonders of the world, and one of the ones I picked is this instrument here, stereo microscope. For the entomologist, it's a way of becoming part of the insect world. Insects are little, they're too small to just take in fully with the naked eye. Put them on the stage of this microscope, and you are suddenly the size of an insect. You feel you're standing at the edge of their field of activity, peering in. In fact, I can't talk loudly when I'm watching insects through that microscope because I have this feeling they're going to hear everything I have to say, and I have to whisper. You watch what they do, you watch them interact, you watch them eat, you put in a male and a female, you can watch them court. And I'm right in there with the critters, looking at them close up, sneaking up on them from behind a tree and looking how they play on the lawn, so to say. I wish whoever watches this could peek through the microscope. It's not the same thing as watching a television screen. That's 2 dimensions, it's flat. Through here, things really are lifelike. When my grandson was about 6 years old, I sat him at the microscope. He learned to focus within a few minutes. And before you knew it, he had one hand moving something on the stage, the other hand focusing the microscope, and he was spellbound. I took a photo at the time. I said, "Nicholas, look up at me." And he looked up from the microscope, and I snapped the picture. If we're going to raise a whole generation that cares about the world and gets involved with the world, I think it's going to be by making it easier to take part in the events that transpire in nature. And this is one wonderful way to do it. Just think of every biology class, right? The very first one to children 6, 7 years old. Sit by the stereo microscope and peer into the screen of the world. They might give up computers for a while. They'll certainly give up television. I mean, this is infinitely better. I'm actually fairly good discovering things in nature. And I make it a point periodically when I have the time to just wander out there without any preconceived notion. So you look under a rock, you find a beetle that makes popping sounds when you pick it up, and that becomes a segment of your life. One of the most exciting photographs we ever took is this particular one. It's the photo of a beetle called a bombardier beetle. It was not only exciting to take the photo, but the beetle was our partner. Actually, the beetle, in a way, took its own photo. To tell you about that story, I have to go back a bit to the life of Charles Darwin. He saw a beetle that he wanted, then he saw a second beetle that he wanted, so he had one beetle in each hand. And then he saw a third beetle that he wanted, a common predicament. So he did the logical thing, which every red-blooded entomologist would do. He took one beetle, popped it in his mouth, with a free hand reached for the third beetle. But as he then says, he felt a hot, irritating sensation in his mouth. which caused him to spit out the beetle in his mouth, to lose the two in his hands, which says something about dexterity and greed. But I'm curious as to what the beetle might have been that gave him a, quote, hot, irritating sensation in his mouth. Because there are not many beetles that will do that. But the bombardier beetle is one of them.
What I'm going to do now is I'm going to pinch very lightly one leg after the other, just as if I were an ant biting these legs. I'm going to start with the right hind leg, right front leg.
The bombardier beetle, as the name implies, bombards when you pick it up. It gives off a spray from two glands that open in parallel on the tip of its abdomen like a double-barreled gun emplacement. In fact, the tip of the abdomen can rotate in all directions, so the beetle is free to shoot and aim no matter where the problem.
I'm going to take him off the wax, which is very easy to do. Oops. Well, you probably heard that. He just fired. I felt it because the spray is hot.
When he shoots, he makes a popping sound. That is an ability that you can take advantage of, because if you take a microphone and put it above the beetle, hook the microphone up to an electronic flash so that the flash is fired in response to a sound stimulus, you can take a photo of something that makes a popping sound. So what you do, and that's what the picture shows, and it's that that triggers the electronic flash, and that's how this particular picture was taken. Now, you can do something interesting. You can measure the temperature of that spray relatively easily by using an electronic thermometer. We knew what the chemical was that the beetle shot out, and we knew the concentration of the reactants that went into generating the explosion. So we could predict how much heat would be produced in the reaction, essentially the temperature of boiling water, 100 degrees centigrade. So we were emboldened by a prediction, but frightened that we might be wrong. That's what sort of drives you. You then build the equipment to make the calculation. You sit at the edge of your seats, and if it comes out, if it matches your prediction, you can't sleep that night. You're the only one in the whole world who has a piece of information. Nobody else has it. You actually don't necessarily want to share it. You just want to keep it. But that's what drives you in science, and I never forget that day.
Okay.
The thermometer is on.
And there we go.
Yeah.
When
10,
we saw
20,
that deflection
50,
on the oscilloscope that told us that the temperature was 100 degrees, I mean, that's when you feel like, well, like heaven. To our knowledge, it's the only case where nature engenders an explosion at the temperature of boiling water. Oh, that. My whole mindset when I pick up an insect is, how are you protected? And we've come up with countless defenses. In fact, I can spend the rest of my life just looking for insect defenses. I noticed early on that insects had powerful odors, that some of them turned on a stink when you disturbed them. And that made me aware at an early stage that there was a lot of chemistry associated with the life of insects. My father was a chemist. My father was an amateur perfumer. He used to make all kinds of concoctions in the basement, and the house sometimes was just infused with this redolent magic. One of the things that drove him to obsession is to try to figure out the formula of eau de cologne 4711, which he eventually did. He made 4711 for the family, and we used to defy people to tell the difference between his imitation and the real thing. But in the process, of course, I kept smelling these things, and I'd ask him where these chemicals come from, and he says, well, they actually come from essential oils. They come from plants, which made me wonder why plants have these odors. It's much later that I realized that these are very often compounds that protect the plant against insects. Well, then I got interested in why certain insects that I was playing with had odors reminiscent of plants. Now, we know that some insects have evolved exactly the same chemical defensive substances that plants do. So I grew up as a naturalist with a nose that was often making more powerful sounds in my brain than the eyes and the ears were. One of the real marvels is insect courtship. They're very good at finding one another, and once they do, they're very good at producing eggs. One of the nicest stories of insect courtship was discovered by an electrical engineer a little over 100 years ago. This is a man called Hiram Maxim, who was one of the great competitors of Edison. Edison was the prime electrical engineer in the country at the time. He wanted to electrify America. Well, so did Hiram Maxim. Hiram Maxim wanted to use direct current, and Edison wanted to use alternating current, and the debate was on. Well, Hiram Maxim was asked to install electricity in the Grand Union Hotel in Saratoga Springs, one of the great spas in upper New York State at the time. So the job was to install arc lights in the garden so one could have wonderful dances in the evening. But he also noticed something interesting. One of the generators, which was giving off a high-pitched sound, was attracting insects by the hundreds. He didn't quite know what these insects were, but he collected a handful, had them identified, and he was told they were mosquitoes. And in fact, they were all male mosquitoes. So he took a close look at them. He found they had these feathery structures on the head, and he said, gee, maybe they're ears. He noticed that when he played sounds to the dead mosquitoes, the antennae, which were like little feathery structures on the head of the mosquito, the hairs on these antennae would vibrate as he put it in unison. Maybe they vibrate in unison when they hear a sound that means something to them. Maybe it's the flight sound of the female that attracts the male, that these two males and females find each other while flying about at dusk. He actually tried to get this published, wrote it up, sent it to various scientific journals, got turned down, also sent it to the London Times, which accepted it and published it. And to this day, this is the first publication on sound used in courtship and insects. It's a real pioneering publication. By the way, Maxim lost his debate with Edison. America went alternating current, and he was so mad that he left the country, went to England, and dedicated himself to manufacturing weapons. And that's what he's best known for, the Maxim gun. He was eventually knighted. I think it should have been for discovering that mosquitoes court by sound, but in fact he was knighted, I think, for making weapons. Within music, if I have to do some picking, I would narrow it down to two composers. That's Mozart and Bach. There are some performances that I can listen to over and over and over again. I mean, to me, for example, the greatest Mozart recordings, or at least Mozart operatic recordings, are the early Glyndebourne recordings from the 1930s with Fritz Busch conducting. There's a personal connection there. Fritz Busch was a good friend of my parents. We were all refugees in South America, and he frequented the house and took me on as a piano student for a while. He was a conductor in Germany. He was conducting the Dresden Opera, and he early on confronted the Nazis. He objected to the firing of Jewish musicians. In fact, in due course, early on, he and his family had to leave Germany. As a youngster, I was impressed by someone who made correct political decisions at a time where many refused to take action when Hitler raised his ugly head. It's interesting that we have a sense of music, isn't it? That we appreciate sound arranged in variation of loudness, frequency, spacing. And I think this relates to our use of human language, which in a way is a kind of music. But we're so busy with deciphering meaning that we don't let just the emotions of the impinging sound do their job on us. But the fact that we can find music in bird calls, or even more impressive, in whale songs. I'll never forget the first time I heard whale songs. They had been recorded by a close friend of mine, Roger Payne, a biologist whom I'd befriended when he was a student at Cornell. And he was at Rockefeller University at the time. He says, "Tom, you've got to come down, you've got to listen to something." And when I went down, he said, "You can't listen to it yet. We have to have dinner, we have to have a glass of wine." Then he took me to his studio, put earphones on me, and played the whale songs. And it was being in a dream and landing on another planet. But it was familiar because the sounds fed into one's appreciation of music as engendered by ourselves. It was truly composition by nature. I think it was an essential component of the appreciation of whales as endangered species. It evoked the feeling of compassion for whales that manifests itself in at least some efforts on the part of humanity to conserve this wonderful series of species. Having a sense for the beautiful in music can be a tremendous source of personal pleasure. I really don't know another way to put it. I dream occasionally that I'm an insect. It's actually very weird because I speak in my original tongue, German, to other insects. And one of the weirdest dreams I ever had was telling an insect that I occasionally dreamed that I'm a human. When I woke up, I was sort of in this twilight zone. I didn't quite know what I was. There's a beetle that I fell in love with a long time ago. It's a little guy, less than 10 milligrams in weight. You try to pull him off the leaves that he's crawling on, and you have a very difficult time. You can hang a 2-gram weight from his back, which is equivalent to several hundred times its body weight. And two things you wonder about: why does he do this and how does he do this? Why is very simple. Ants can't prod him loose. And he can withstand the attacks and prodding actions of an ant. In fact, we've taken very nice close-range photographs of such attacks. We now know how he clings. It turns out he's got 60,000 bristles on his feet, on his 6 feet. The bristles are wetted by tiny little drops of oil, which at the tip of the bristles function just like a drop of water between two pieces of glass. You know, if you've got two pieces of glass squeezed together with a thin film of water in between, you have a hell of a time taking them apart. How does the beetle walk away? He rolls his feet off one row of bristles at a time. When he's attacked, he presses the feet flat down on the surface, and by so doing commits 60,000 bristles to contact with that adherent oil. That's enough to glue him down. When I was little, I I spent a lot of time trying to draw what I saw. I mean, I was raising butterflies. I would draw the egg, then I would draw the caterpillar, then I would draw the pupa, then I would draw the adult, but it was terribly laborious. Then I came to the United States as a teenager and discovered photography as something that one could actually do as part of one's work on insects. And I've never returned to drawing. I love to photograph. I mean, the idea of being able to depict on a flat sheet of paper or on a transparency that you project on the wall an image that's virtually alive is phenomenal. I love to photograph with an instrument called a scanning electron microscope. That is an instrument that gives you further magnification than the stereo microscope and these microscopes that I have with me here. You get only black and white pictures, but you get pictures with tremendous depth of field. Nothing is out of focus. There's a special technique for immobilizing the insect in this fashion. You stage the encounter in the laboratory on a trap door, and when the right thing happens, you basically drop the contenders into a chamber which is at minus 160 degrees centigrade, which is as cold as you can possibly imagine. And the result, sadly, is instant death of the insects. But they're immobilized in the exact moment. You then dry them by vacuum, and you have them permanently preserved in that particular behavior. This is a fruit fly immobilized in flight. It flew into that freezing temperature, and you can see it in the exact moment of its wings being in the upbeat. This is the left wing. You know, flies only have two wings. The hind wings serve as balancers. Here's all that's left in the hind wing in this particular animal. They're gyroscopes. They allow the animal to keep in balance while it's flying. This shows an attack by a termite upon an ant. Termites and ants compete for space, so they often get into trouble. And what you can see here is the termite has bitten down on the legs of the ant. The ant's probably done for. And just take a look at the detail here. On the head of this termite is a tiny little parasitic mite. So you can see a great deal of detail. Here, for example, is a so-called nasut termite. This is the soldier caste of a termite. The head in these termites consists of a big capsule that's filled with a gland that puts out a sticky material, which the soldier, when it wants to fight some intruding ant, for example, shoots out through this nasus or nasut. You can even see a droplet of secretion at the tip of the nose. I love this one. It's a group of Mexican bean beetle larvae. To me, being able to see something close up like that is in itself, you can't call this science, but it's feasting on your eyes, so to say, or improving on your eyes, taking you to a level of dimension and magnification that the eye is not capable of. Well, I was, like probably most children, fascinated by death, but I approached it experimentally. I wanted to know what happens to a corpse after it dies, and I knew that it was reduced to bones eventually. Well, somehow I was curious about how long that took, and I asked my mother, how long does it take for a human to become a skeleton? And my mother was an artist. She believed in answers, not necessarily researched answers. So she said 2 years. And I worked on the assumption that it takes 2 years for a corpse to turn into a skeleton. But I decided to test this out. And we lived in Montevideo on a street where occasionally small animals were hit by cars. So I took a roadkill, buried it where I could check on it without being observed, and found that it was converted into a skeleton in the summer in a matter of weeks. So I decided that it happened a lot faster, but I also found out how it happened, because I would check on the corpse every day, and I realized there was a whole succession of corpse eaters, mostly insects, grubs, beetles, that came and devoured this corpse. And I suddenly thought I'd made a great discovery on how corpses get converted to skeletons. Being an arrogant little kid, I thought I was better at getting some information than my parents were, so they were good at some things, I was good at others. I think the greatest wonder is what remains to be discovered. And this I associate with what is hidden in terms of discoveries in the biotic world, the chemical and genetic information of nature. Let me give you an example of a plant that we've been working on for the last several years. It was only discovered about 30 years ago, 1962 to be precise. It's already on the endangered species list. Its entire range is a few hundred acres. What really stunned us about this mint plant, it turns out that many plants harbor fungi that grow within them. This is the plant's way of having a built-in drugstore. The fungus, by growing inside the plant, is nourished as if it were a parasite, but it pays for the lodging, so to say, by producing chemicals that are useful to the plant. And one of these fungi produces a very powerful antifungal toxin, in other words, a substance that's potentially used as a medicine against fungal infections. So here is a species which is on the American endangered species list with fungi within it that don't even have a name yet. Now imagine if that plant had been lost. Quite aside from the intrinsic implications of the loss of a species, which I think is a terrible tragedy in itself. Think of the information that would have been lost with it. The genetic information in a species, in just one species, can be compared to all the information that's stored in something like the Encyclopedia Britannica. And look at how many species there are out there. We protect museums, libraries with sprinkler systems in case of fire. We have nothing equivalent to protect nature, which is the most valuable storehouse of information which we have. Some say there are 10 million species out there, others say there's 100 million. But the truth is most species have not even been discovered. We can simply say the greatest wonder on our planet is the wonder of the undiscovered, the wonder of what is yet to come.